Welcome everybody. This is going to be a video presentation on AFO, AIRCOFRIDGE Optimizer, and we're going to be studying the improvements that we have as compared to standard regular R22 mineral oil for refrigeration and air conditioning systems. What I have is I have a lubricity tester here, and what this unit is this is a 1/4 horsepower motor that simply just turns with belts, turns this shaft that will have an oil bath in, and what it's designed to do is find the failure point to a lubricant. We're going to apply pressure with this torque wrench, just a standard Craftsman torque wrench, and at a certain given amount of pressure a lubricant can no longer overcome the friction and it will lock up the motor and the shaft. When we do this, we're going to look at how many pounds of pressure it takes to do that, and we're going to watch the amperage and see what it's like at idle and what it's like when it has a load on there, and see what the difference is between standard refrigerant oil and AIRCOFRIDGE. We're going to do 4 tests on this unit. The first test is I'm going to turn this on. We're going to apply standard refrigerant oil into the oil bath. Once we have some there, which we can see, this is a Timken bearing, a very hard steel bearing. This is just a standard roller bearing, a lot softer metal. And what I'm going to do on the first test is I'm going to apply pressure, find out where the failure point is. We'll take a look at the amperage at the same time, and then after doing this a little bit, this softer bearing is going to have a significant groove cut into the metal surface. The second test I'm going to do is to take this bearing, I'm going to turn it a 1/4 turn and duplicate the same test again, and then we're going to add AFO to the solution. This is going to show you a before and after on your used equipment. The third test I'm going to do is I'm going to take the bearing, turn it another 1/4 turn, so we have a new surface and an oil bath treated with AFO. And now we're going to see the improvements on new equipment as compared to the older equipment on metalware. The fourth and final test will be to take the bearing, turn it another 1/4 turn, remove the oil bath completely and wipe everything down. And this is going to signify the dry start. When the HVAC equipment has been turned off overnight, all the oil is down in the sump and there's nothing there to lubricate when it calls for cooling. All we need is a few seconds of protection, so we're going to see if the AFO can give us those few seconds of protection. So let's go ahead and get started. I'm going to turn on a decibel meter here so we can measure that as well. So what we can see is, starting out, we have an amp meter that's showing we're at 5.1 amps unloaded. The decibels are maxing out at 97. And let's go ahead and apply pressure and find out where the failure point of this lubricant is. We can hear it begin to fail at 15. And at 20 it locks up, at 25 it definitely locks up. Now we can jump over and look at the amperage. We're at 5.1 unloaded. 7 amps just before it locks up. The decibel meter peaks out at 103. We actually exceed the limits on the decibel meter. At the same time, if we're able to zoom in, we'll notice some significant metal wear on this bearing. Now I'm going to take this, turn it a 1/4 turn, and I want to duplicate the same thing again so we have 2 identical like surfaces. So again, at 15 pounds of pressure, we can hear it start to fail. At 20, we got full failure. And almost at 7. If you look, we have a significant amount of smoke coming off of this unit. on to this. And let's see what happens. Let me clear out the decibel meter. .1 amps unloaded. Here we're at 15 pounds. This is when the unit began to squeak and we began to notice failure. Here at 20 and 25 we had full complete failure. If you look, our decibel level is at 97, significant drop, which of course I'm not having to raise my voice. And the amps, we've moved 1/10 of an amp compared to where we were at 7 amps as the unit thought when it was under a heavy load. Now, when we're done with this demonstration, we had two identical surfaces. The metal wear on this second one, now that it's been treated with AFO, has now been polished mirror smooth. That is going to help with the vibration, with the sound, and the overall running of the equipment. So now we move on to the third step. I'm going to take the bearing, turn it another quarter turn. Those last two tests represent before and after on used equipment. This test is going to represent new equipment. We have a new metal surface and now an oil bath treated with AFO. Let's see where we end up. Again, we're at 5.1 amps unloaded. We're at 15 pounds of pressure, was where it was dying at before. 20 pounds to 25, where we were having complete failure. And the decibel level reading, we're sitting right about the mid-90s. Still at 5.2 amps, we moved a 1/10 of an amp. Now the important thing to remember is, on the previous test, I was applying pressure with this torque wrench on and off, on and off. With this one, I've kept a consistent 25 pounds of pressure, so we should expect to have some significant metal wear. Let's take a look and compare, if we can zoom in, on the metal wear that's there. We've barely dented the surface. We've just mic'd it. So you can see where the AFO is going to extend the life of the equipment. If we can reduce the metal wear, we're going to add life to the system. Now, for the fourth and final test, I'm going to remove the oil bath and represent a dry start. Here I do want to show, I have a magnetic tool here. All these metal shavings, this is contaminants that can enter the system, clogging up filters, but basically showing overall damage internally into the system. This is what we do not want to have inside a hermetically sealed system. So, we want to represent the dry start. I want to turn this on, remove the oil that's there, and what we're looking for is 2 to 3 seconds of protection so that the unit can get the oil pump working, or the oil bath will splash up and coat the surfaces. Here we are at 15 pounds. This is where we had metal or lubricant failure before. 20 to 25 pounds where we had complete failure. We've obviously passed the 2 to 3 seconds of protection that's needed. Also, you'll notice we're at 5.2 amps. Still, we've only moved a 1/10 of an amp. Clear out the decibel meter. 95, 96 is the peak amps, where we had maxed out the meter at 103 before. So even with no lubrication at all, this is where the unit was failing before. Now let's check the metal wear. If we can zoom in, we can see there is no metal wear. The AFO is bonded on and become a boundary lubricant. Now, some of the things that we can do is we can find out where this unit will actually stop at. Where is its failure point? So with this, I will borrow Joe. I'm going to put a drop on my finger and drop on the race. Joe, if you'll come help me out while I hold this unit. Joe, you're going to need 2 hands. Here we are at 75 pounds of pressure. Joe, do it fast, do it slow, do it however you would like. Okay. Obviously, a 75-pound torque wrench is not enough. We have another one. This one goes to 140 pounds. So it's about 120, 130 where this unit is failing. If we can see, we're jumping up to right around 5.3 amps at 100 psi on the torque wrench. When we pull this off, we can zoom in on the metal wear. We even have a little bit of smoke rolling off of this thing. It got very hot, but you can see even the heat will not take the AFO off of the metal surface. Here we have barely damaged the surface. You can't tell any difference from before. So this concludes the demonstration on AFO on the lubricity tester. And thank you for your time.